YouTube is not for you to watch if, oh, we're online, excellent. Let's just switch to a different tab so it doesn't recur to the recursive thing. YouTube is not really for you to, it's really a supplement in case you missed something in class, you were here, and you get, let me just go teaching. And today I must really catch up. So I'm going to assume for once, I'm going to read individuals and assume that you have read the work, that you already know a little more than I do, and that I can go quite quickly. So I'll try to be on capable for that. So you can do the tutorial tomorrow. Variables and types on Monday, more. But there are two types we haven't really discussed much. One is strings. And the only thing we know how to do with strings is to concatenate with a plus sign. And the other is booleans, which you're maybe slightly unfamiliar with because booleans are not something in school. You probably didn't study booleans at school, or did you do that in AP Maths? Did you study Boolean algebra in AP Math? No, it'll be on fine. Okay. So booleans are kind of new, but they're extremely useful and important in computer science. We use them all the time. There is no program that does not contain booleans. So we already know a system of the print line. That's our first what we know statement. We know variable declaration, and we know variable assignment. And these booleans are part of variable declarations and assignments. But let's have a look at how to use them. So if I declare a box to put a value inside, that box can only contain one of two values. It's either true or false. That's easy to understand. If we write true or false in Java, they're called literals. A literal is an actual value, like it's a value that you can type in Java, and you can type true in Java or false in Java. Java knows those words. It's part of the set of keywords that Java uses. There are a couple of operations on booleans. So for integers, we have plus, minus, divide, remainder, and multiplication. For booleans, we have these three operations: and, or, and not. And we don't write and, or not. We write double ampersand for and, double bar for or, and an exclamation mark for not. And the meaning is that if some variable a contains a false, then this expression, not a, will be true. And if it's a true, it will be a false. So whenever you have an expression, I ask Java to system.println a plus b, and a and b are integers. It will calculate the value of that expression. It will fetch a, it will fetch, look at what's inside box b, and add them. And that value is what it will print. In this case, if I write not a and a contains a boolean, it will print true or false. We'll see that in a sec. And then if a and b contain false and false and false and true and false and true, here are the values that a and b compute. So if I'm asking Java to compute the value of a and b, meaning a is true and b is true, this whole expression is false unless both are true. So it's only in this one case, true and true, that I get a true result. And the same for or. If a or b can be true, in which cases is that true? Well, if both are false, then a or b is also false. But in all other cases, it's true because at least one of a or b are true. So these are booleans. I say we use them a lot. We'll actually be using them a mega lot from next week on when we start doing ifs. But for now, we'll be having assignments and doing calculations on these kinds of expressions. If I have two booleans, I can combine them with these operators and or not and get new booleans. If I have two integers, I can combine them and get new integers. new integer values. Booleans are a little different because I can also take two integers and make a Boolean out of them. So I can compare two integers in different ways, or two doubles, or maybe even two Booleans, and get a Boolean result. So for example, there are these operators, equals. 2 equals 2. If I write that, then I get a Boolean, false. In this case, 2 equals 2 will return a true, or will be equal to its value is a Boolean, it's true. And 2 equals 3, its value is a Boolean and it's false. Not equal, so it's very important. One equal sign in Java means, and it's somewhat arbitrary, but that's the way Java works. And loads of other languages work as well. Means equality, means assignment. You mustn't confuse the two, and Java will try to warn you if you do, but it can't always tell. So if I want to write equality, compare two values, I have to write two equal signs next to each other. If I want to write inequality, not equal, it's exclamation mark equal sign. Just less than or equal is less than, immediately followed by inside there. No spaces between the exclamation mark, no spaces between those two equal signs. Right. Greater than works the same way, greater than or equal to. So, for example, let's say we're calculating quadratic roots like we did on Monday, and I want a Boolean to tell me what will be under the square root sign is positive, or at least non-negative. Because if it's not, I can't take the square root. So I want the discriminant to be positive or non-negative. I can write a Boolean that computes that value for me. I can write this expression in parentheses, so it'll be calculated first. And we know all this, it's b times b minus 4.0 times a times c, greater than or equal to 0.0. And depending on the value, this will either be now the Boolean is the discriminant. Is this the beginning of a century? Year modulo 100 equals 0. So some people find that a little more tricky. But just remember, modulo is what you have left over after you divide. So it's the remainder. I take a year, any year, 1981, divide by 100. 100 goes in 19 times, and the remainder is 1. So in that case, year mod 100 would be 81. 81 is not the start of the century, obviously. It's only the start of the century if that remainder is 0, 1900. 100 goes in 19 times, remainder 0. So I can use this check to see if I'm at the start of a century. True if I am, false if I'm not. Is this a legal month? Is whatever is stored in the month variable greater than or equal to 1? And also smaller than or equal to 12? What do you want? Oh. Let's rearrange things. Do it like that. Just put that there. Go to this window. Close this all up. Make a little terminal. And bigger so you can see it. And go inside our Booleans. And I'll make this a little bigger. Public class Booleans. I must remember to make it the same as so this Booleans must store in a file called Booleans. And this stuff is so routine. We do this every single time. And for you, the Afrikaans for Boolean is verleese. So verleese waardes. New Boolean to know that because they're really good. Okay. Oh, missed out. And see what the compiler says. Public void static void. Oh yes. Int month will be 5. Int valid month is month greater than or equal to 1 and month less than or equal to 12. Okay. So that code there in line 6 will calculate the value of this expression. This first one is a Boolean because I'm comparing two integers. The second one is a Boolean because I'm comparing two integers. And Boolean gives me another Boolean, which will only be true if they are both true. So if both month is greater than or equal to 1 and month is less than or equal to 12, that'll be a true, which I'll store in this assignment statement inside valid month, which I'm declaring. So this is two statements and a lot of expression evaluation all in one. Yes?
Why is it valid month integer in the Boolean is that false?
You ask a good question. Okay, right. Usually, I'd be tempted to start handing out money for people who can spot mistakes. But there are so many mistakes. Just like that, I bankrupt the university. All your student fees that must fall will be paid back to you in terms of mistake money that I've made. Mistake number 1. What's your name? Matthew. Oh, like the disciple. What does it mean?
I don't know.
What an odd meaning for a name. Yeah, fine. Yes, Matthew. What's the first mistake? Imagine that I'm an attractive little first-year student sitting there, crying in the lab, and you come over, you want to help me, and I've just typed that. What would you say? Hey, baby, what's your number? What you doing? No, you say, shouldn't that be booleans.java? Oh, you stupid little first year. Okay, fine. So now we get loads of other mistakes, and predictably, well, let's see what it says. Infile booleans.java, line 3, expected an identifier, points me to our mistake. So I'm still not exactly sure what that error message means. I don't know what an identifier means, but just by Java pointing to that mistake, I know what the mistake is. It's this lot where I left out main string args. Save it again. I'm going to clear the screen. Okay, fine. Now Java's unhappy because of the mistake that Matthew pointed out. So the message is that in booleans.java, in line 6, there is an error. Incompatible types. A Boolean cannot be converted to int, meaning that it's pointing to the ampersand, but that may be a little confusing. But what it's really pointing to is the whole value on the right-hand side. And the ampersand is somehow the root of that structure. I'm ANDing the left-hand side and the right-hand side, and they have their own issues, but the result of that AND is a Boolean, as I've explained, and I'm trying to put it inside a box that I said was an integer. I said valid month was an int. So that's clearly the mistake, and I have to change it. Boolean. Java's happy, and we know that this program will do nothing, but let's write out valid month. Is 5 a valid month, Matthew? So what was print? Do you think? I have to run it. Okay, excellent. And let's just double check. Let's go for month 15. Compile. And that's false, because 15 is not a valid month. 15 is greater than 1 or equal. So this side is true. But is 15 less than or equal to 12? No. So that's a false. And true and false is false. Right? It's only true if both sides are true. Okay, fine. But what I actually thought of showing you is that students often, I've been teaching first years for at least, I don't know, 20 years. And students often make the same kind of mistake over and over. So in an effort to prevent that every year, I show you this little piece of code. I'm going to call it something else each month. Right? Students often want to write 1 is less than or equal to month, less than or equal to 12. Okay, excellent. I've made this little shortcut. Unfortunately, Java is not happy, because if I write this, Java will read it and say, well, that's an integer, comparing it to the integer month. That's fine. We get a Boolean. But then I have a Boolean. And I'm writing less than equal, and that's an int. And I can't do that. I can't compare a Boolean and an int with less than or equal. So this whole expression is broken. Let's see if we find out what that's good. Let's see what Java says about it. Oh. 7, there's an error. Bad operand type for Boolean, sorry, for binary operator less than or equal to. So I can't use less than or equal to with a Boolean on this side and an int on that side. First type is Boolean, the second type is int. Those types aren't compatible in that sense. You don't get right. Good. So that's Booleans. That's the whole program that prints whether a given year is a leap year or not. And we should work. So the program is called leap year. It has main string args, as all our programs will in this term. I declare an integer called year. I take arg0, which is a string, and I send it to this function, integer.parseInt, which converts a string to an integer. So in this variable here, I now have the year, 2016, 2018, what have you. Then I declare a variable is leap year. It's a Boolean, so I can put true or false inside is leap year. And each leap year is equal to something and something else. So it's equal to year mod 4, the remainder after dividing by 4, is 0. So 4 goes into year evenly. So it's a year, like 2000, 2004, 2008, 2012. And that's because every 4th year is a leap year. So that'll be true if it's divisible by 4. And year mod 100 is not 0. What? Okay, who has seen a leap year program before? Be honest. Okay, you guys must not answer. Who has a morbid fascination with leap years and the calendar? Don't lie. I do. Calendar is fascinating. So the calendar has changed a lot over the centuries, and in some places they decided to switch to different calendars. And they lose a couple of days, or suddenly it's a Saturday, the next day it's a Tuesday, things like that. And then some countries, what?
Do you prefer Julian or Gregorian?
I like all calendars equally. It's like choosing your favorite child. Okay, right. So some countries they switch to a calendar and then they decide, oh no, this is too much. Switch back. There's a different date that they switch back to. So it's chaos all around until the 20th century. We still have different calendars, but ours has an interesting feature. When is a year a leap year? Every 4th year is a leap year. but every 100 years is not. So 2000 was a leap year. Well, let's hear about 2000. 2004, let's go back. I can't go back. I need to go back to 1892. 1892, 1892. Divisible by 4, so it's a leap year. Okay, now I want to write comments. I want to write somewhere. So I'm going to use that comment thing we learned about. 1892. Divisible by 4, so yeah, leap year. 1896. Divisible by 4, so it's a leap year. 4 years later, 1900. Divisible by 4, yes. But when it's a change of a century, it's not a leap year. So this is not a leap year. 1904, leap year. And this is because if we add the centuries as well, we have too many leap days. So because the Earth's rotation is not perfect, it's not 365 and exactly 1/4 day. We can't just always add a leap day every 4 years. Some years we have to skip. I'll get back to you. I know what you want to say. I can sense it. I can sense it.
But why is 2000?
I don't know what kind of crazy stuff you're thinking. You don't want that in this class. Okay, so 2000 was a leap year. Because if we leave out all the 100 years, the change of centuries, then we're throwing away too many leap days. So years, we do have a leap day. Okay, so ... 2000 was a leap year. Even though it's divisible by 4 and 100, it still was a leap year because it's also divisible by 400. It's just the way that the life works. Get used to it. Your generation is things alive. Yes, good. What do I ask for? I'll just say leap year. Okay, Google, leap year. Okay, good. Google responded. Okay, it's sure to be on the Wikimedia page. Just give me a second. Come on, I want the exact calculation. I'm looking for that exact number. I haven't passed it. That's not exact enough. Oh, here we go. So every year is actually contains 365 point. 0.2425 days. And all these shenanigans. When is leap day? In a leap year, when is leap day? Oh, that's incorrect. A leap day, the day that's inserted is actually on the 15th of February. And all the days move one on, and that's why we get 29. Just a fascinating piece of trivia. Now, even that is not accurate. What? Why? Romans, who knows? Even that is not accurate, which is why we still need to add leap seconds every couple of years. Every year, your clocks are wrong. Not every year, but every couple of years, your clocks will be wrong by 1 second because the time is advanced 1 second to make up for this rotation. Your trust levels are disappointing. I'm wasting time. I thought your parents would educate you, but stuff like this. It's a 1 second adjustment. The last one we had was at the end of 2016. We advanced the clocks by 1 second, quickly. Nobody saw, but well, let's get back to science. We have this first formula, which says if it's divisible by 4 and not by 100, then it's a leap year. But now we've made a mistake because we haven't taken into account every 400 years, again, add back the leap year at the turn of the century. So now I say it's a leap year if it's a leap year as calculated above, divisible by 4 but not by 100, or if it's divisible by 400, then it's also a leap year. So either if it's a leap year as I define it here, or it's also divisible by 400, we say that it's a leap year. And then we print it out, and then this whole thing actually works. Program works with 1900, it says false, and for 2000, it says true. Are you Googling leap day? I knew it. I can sense it. Am I correct? Was it the 15th or the 23rd? Now I'm beginning to doubt myself. It's not the 29th. Okay, fine. Good. Everybody's happy. We have to talk about strings. But before I do, I want to talk about this because arguably this is more important, especially for tomorrow's stuff. Sometimes I have a box that's supposed to be for integers, but I want to put something else in there. I want to put a string in that integer box. And Java has functions that will help you do that. For example, that integer.parseInt takes a string, turns it into an integer, if it can, and puts that, I can put that into a box. Sometimes, however, there is no function available. And Java has some built-in mechanisms that can help me to convert one type to a different type. So, for example, we've already seen this one. Where's my cursor? We've already seen that, I've told you in class, that if I try to add a string and an integer, Java will say, even though this is a valid integer inside the string, I'm not going to convert it back to an integer. I'm rather going to take the integer 99, turn that into a string, and then I'm adding a string to a string, which is concatenation. Samenvoeging. Is it? Okay, right. We've seen this one, which will take a string and produce an integer. So here we went from integer 99 to a string. Here, this function allows us to go from string to integer. If we have a double and we want to say, I want to make you a string, we can write this operator in front of it. So parentheses, int parentheses. And it will turn it into a string by throwing away the real part. So it's just keeping the integer part of the double, the whole number part. And it throws away the 0.71828. And we've looked at this math library before. It has loads of functions that will help you. Well, I say loads. There's 3 functions that will help you to convert from type to type. So there's round, which rounds to the closest integer. Not down to 2, but up to 3, because 2.71 is closer to 3. I can take what that gives me, which is actually something called a long, and make it into an int. So I can put it inside an integer box. So round will give me a 3, but it's something called a long, and I make it an int, and it becomes an integer 3.
So is that the full command here, right?
I will.
The int, just the indication. The int between brackets, is that also part of the language?
It's part of the language. Let's write it. That's why we have the editor. Edit rounding.java. I'm going to steal the previous one. Put the new stuff here. Okay. Oh, I've got to call it rounding. I'm not making mistakes. Let's call it E, because that's what it's called. I. Let's make a couple of mistakes. Let's make some more mistakes. 1, 1. And apparently I've been making mistakes all along. Because assignments, declarations must always have that semicolon at the end. It tells Java when the statement has finished. Okie dokie. So without even printing all this stuff, let's compile it and see what happens. Let's compile. Oh, many mistakes. 4 mistakes. First one in line 6. Incompatible types. Possible lossy conversion from long to int. It's not happy about E1 and Pi1. And the same here. Possible, incompatible types. Possible lossy conversion from double to int. Can't just take this double and put it inside an int box. Now the only mystery here is what is a long? It's what you wanted to ask, isn't it? So a long is a secret integer that I haven't told you about, so I didn't feel you were ready. But I feel I can sense now that you're emotionally available to hear about longs. So some need really, really big integers. So big they can't fit inside an integer box. And then we can put them inside a long box, which is almost literally double the size of it. And it can hold much larger numbers. Now, this always use because I can store just bigger numbers and small numbers as well. But there are some penalties for using longs. So when people just want an int, they use int. And it's only when they know it's going to be a problem that they switch to longs. There are crazy people who use longs all the time. No comment. Okay, right. So I can't fix all of this, but I can definitely fix this by, well, I don't want to just add back the int in front because then it'll be the same as above. But we can change this variable to long. Oh, well, while we're at it, we might as well change this to double. And now everything will fit where it's supposed to go. Good. Java's happy, I'm happy. Okay, fine. There is type conversion going on here. Java is actually converting type. What Java sees is Duck is trying to multiply 11 by 0.3, but 11 is an int. It's also a real number, that's true, but if Java just sees 11, it thinks int. It's multiplying that by 0.3, which is a double. So it will convert 11 to its integer, to its double counterpart, 11.0, and then it will multiply those two doubles, and it'll change into 3.3. Same thing here. Int operator is very strong. I apply it to 11, which is already an int. It stays an int 11. I multiply it by 0.3. Java says, oh, int times double. I'll just make the int into a double, so that'll be 11.0 times 0.3, and the answer is the same as above. If I put the int in front of 0.3, Java will say, okay, 0.3 is a double, but Jack is forcing me to make it into an int. So I just throw away the real part. I keep the whole number part, which is 0. And now I have int 11, the integer 11 times the integer 0, which will give me an integer with the value 0. 11 times 0 is 0. And lastly, integer is very strong. So you saw that it attached to the 11 immediately. If I wanted to do the multiplication first, I have to put in parentheses. So 11 is an int times double 0.3. Change the int to a double. 11.0 times 0.3 is 3.3, which is a double. But then I force it into an int. So Java throws away the real part, 0.3, and it keeps the 3 whole number part. So that's why that says 3. Confusing? No. Excellent, guys. You're ready for the next step. Oh, this is so useful. You must know this. Even if you have to skip strings, which we do. Often we want to have random numbers because we want our programs to behave in unpredictable ways. Like, for example, if you're implementing a game, you don't want it to always behave exactly the same way. Always generate the same world map. Other computer-generated characters always behaving in exactly the same way. Are you thinking why? What? They had a towel, I thought. Heaven. Okay. So this is a little program that generates a random number, like a dice roll. and it uses a function we saw but did not discuss, math.random. What math.random does is, it's a function, but it doesn't take any arguments, and it sends back some value, a random value, a different value every single time, that's somewhere between 0.0 and 1.0. In fact, it never sends back 1.0. It's always slightly less. So random is a function, math.random, that sends back a random value, but only a double and only between 0.0 and 1.0. If I want to simulate a dice roll, I have to get a number that's an integer from 1 to 6. So what I'm going to say is, I'm going to multiply. I'm going to read from the command line a variable called n, which is the maximum number I want on my dice. 6, then n will be 6. And I will invoke the program by saying random int 6. That 6 will go inside n. I calculate a random value. Then I multiply r and n. So if r is 0, then r times n will be 0. And I force it into an int. Then the dice, let's roll a 0. And if r is almost 1, I multiply by 6, I get almost 6. I force it to be an int, but it's not 6, it's almost 6. So then the dice roll will be 5. So this little program will give me a dice roll from 0, if r is 0, to 5, if r is almost 1. This is, what?
So the question is there a discount
No.
On the random thing, except parameters?
Not this random. The random thing does not accept any parameters. No, this is a function and it only has this one form. There are other ways, but it's too advanced for us, for today at least. So actually, I should be adding 1 to this result. Yes, to get it from 1 to 6. So let's quickly do that and then I'll stop. I'll give an Afrikaans summary. I will not stop. I'll just give a little Afrikaans summary. Okay, now I have to type quick. We have to be quick. We call this program random ints. Random ints.java. Random ints. Just dump what I had before. Oh, apparently nothing. Copy that. Oh, it's an image. It can't be. Oh, damn. Okay, I have to type it out. Okay, int n is integer.parseInt of arg0. Stop me when I make a mistake. Double R is math.random. Int result, okay, is the int of r times big N system.out.println. Yes, yes, +1. Okay, you're not my mother. Okay, there we go. I'm kidding. I'm just kidding. It's a little light entertainment. Okay, good. Worked. Random ints. 6. Okay, we threw a 1. 1, 2. I was thinking we are going to throw 1s all our class long. Okay, 5. I rolled a 1, 4, a 2, a 1, 5, 3, 4. Oh, I just, yeah, same thought. This thing is not throwing 6s. But let's do it 1,000 times. 1,000 times. How do I do that? Thank you. Yeah, but how do I do it? Okay. Thank you, but it's still difficult doing a for loop here. Random int 6 and equals. Don't worry about what I'm writing. Just close your eyes. I'll tell you when to open it. Am I making some horrible mistake? Well, probably is this. Not complaining about every single thing that it can complain about. Okay, fine, there we go. And no, stop. Let's just put a file, xt, and it'll run a little while I give up the card summary, and you can check if it's an even-sided dice. So, wat het ons al bespreek? Ons het basies net gepraat oor bewese waardes. Hulle spesiale operators is en, of, en nie, and or not. Maar ons moet daai spesiale simbole gebruik. Dubbele ampersand, dubbel is regop streepie en 'n uitroepteken vir nie. En ons kan ook heel getalle vat en hulle oorskakel na bewese. Kleiner as dubbel is gelyk aan, nie is gelyk aan te gebruik. En ons het ook gepraat oor tipe oorskakeling. Ek kan tipes waardes oorskakel van een tipe na ander, afhangende van wat 'n waarde dit is, maar een tipe operator wat ons geleer het, int akkie. Ek weet dit is 'n baie versigtige opsomming, maar julle moet my vra as julle dit nie verstaan nie. Ek sal probeer om 'n klein bietjie meer Afrikaans te praat, om sit van opgevang. En if you ask me in Afrikaans, I'll answer Afrikaans. Sal antwoord 3 vra. As jy 'n tolking wil hê, daar is nog tolkie hier. Voor julle, ons het nog 2 minute, 3 minute. So, kom ons wag net gou vir hierdie te maak. Of is ek te lui om dit te doen? Te lui. Kom ons kyk net hoe ver hy nou is. Hoeveel het al? Okay, 531. Hy's way. I'm going to what he has. As I sort XOTXT. This all count. We have 89, 98, 1s, 60, 70s, 84, 96. So it's not perfect. It's not entirely convincing, but this is actually quite a small sample. Yes. Oh, why no zeros? Because the program on the side generates a random or a bit from 0 to 5. We actually for. Okay, right. Science has values from 1 to 6. So we added 1, and that's why the 0 disappeared and the 6 appeared. Right. Don't be afraid of questions. I'll see you. Only come to the 30-year schedule, and I'll see the rest of you on Friday. Thanks, guys.